everyone, I am Divya TM. Welcome to the online video of characteristic impedance and propagation constant of transmission line. Agenda: characteristic impedance of a transmission line, propagation constant. Consider a current and voltage wave. Consider ISI as the source current wave, VSI as the source voltage wave, and the length of the transmission line is infinity, where ZIN is your input impedance. So characteristic impedance can be defined as the input impedance of infinite line. It is also defined as the ratio of forward traveling voltage wave to current wave at any point in the transmission line. So consider the voltage and the current expressions of these infinite lines, which is given by V is equal to VSI into e to the power minus gamma x and I is equal to ISI into e to the power minus gamma x. So differentiate these above equations with respect to x. What we get is dV by dx is equal to VSI. Differentiation of e to the power minus gamma x is minus gamma e to the power minus gamma x. But we already seen from the previous derivations, dV by dx is given by minus r plus j omega l into I. Substitute this equation in dV by dx equation. So it will be minus of r plus j omega l into I is equal to VSI into minus gamma e to the power minus gamma x. Substitute for the current, where current is given by I is equal to ISI into e to the power minus gamma x in the above equation. We get this equation. Simplify this equation. We get VSI by ISI is nothing but your r plus j omega l divided by gamma, where minus on both the sides will get cancelled. What we get is, but we already know gamma is nothing but your propagation constant. It is given by square root of z into y, where z is given by r plus j omega l and y is given by g plus j omega c. Substitute for gamma and simplify. What we get, VSI by ISI is equal to square root of r plus j omega l divided by g plus j omega c. This is our characteristic impedance, which is denoted by Z0, where z is given by r plus j omega l and y is given by g plus j omega c. So finally you can also write in terms of x, z and y, Z0 is equal to root of z by y is the characteristic impedance. Coming to the propagation constant. The propagation constant per unit length of a uniform line is defined as the natural logarithm of the steady state vector ratio of the current or voltage at any point to that point at unit distance further from source when the line is infinitely long. So by the definition, you can represent gamma as log of I1 by I2, and gamma can also be represented in terms of voltage as natural logarithm, so log to the base e of V1 by V2, and we know gamma is equal to square root of z into y, and gamma is nothing but a unitless quantity. Thank you.